Part B here is on density. This is taken from worksheet 2 of Unit 9 in Math 3. And we're going to use the density formula, which density is your mass over volume. So iron has a density of 7.87 grams per cubic centimeter. We want to find the mass, and we're given some values to help us find the volume. Here we have a rectangular prism. The volume is going to be 10 times 5 times 2, which is 100 cubic centimeters. And so our density, 7.87, is equal to mass over volume. And solve for mass. I'm going to put this over 1 and cross multiply, and you get mass is equal to 787. And then we want units. If you look at the density, it's grams per cubic centimeter. This is the units of mass. This is the units of the volume. And we're solving for mass, so we're looking at grams. Number 8, we got a cylindrical cake below that has a density of 2.285 grams per cubic centimeter. So again, we see the mass is in grams, the volume is in cubic centimeters. What's the mass of the cake? So let's find the volume of this cake here, which is the area of the base, so pi r squared times the height. So 10 squared is 100, so we have 1500 pi cubic centimeters. And so our density is mass divided by volume. They give us a density at 0.285. We don't know the mass. We got the volume at 1500 pi. So I'm going to cross multiply, and I get mass times 1, which is mass, is equal to 1500 pi times 0.285. So 1500 times 0.285 is 427.5 times pi. If you multiply that times pi, you end up with 1343. We're rounding here, roughly 1343, and we're looking at grams here. We got a bar of gold that weighs 29.4 pounds, so that's mass. If the density of gold is 0.7 pounds per inches cubed, what is the length of the gold bar? So we have density is mass over volume. Density is 0.7. Mass is 29.4, and we need to find our volume first. I'm going to cross multiply here, and I get 0.7 times the volume is 29.4. I'm going to divide by 0.7 and get 29.4 divided by 0.7. Use my calculator to get 42. We're looking at cubic inches. And so in our picture on the right, we know that the volume is our missing value, which we'll call x, times 3 times 2, And we know the volume, we just found it, is 42. So 42 is equal to 6 times x, divide by 6, and we get x is 7 inches. 11 deals with population density, which uses a very similar form. It's not exactly mass and volume, but let's take a look here. The city of Clovis has a population density of approximately 5,000 people per square mile. And so what we're going to work on here is, instead of saying the density is mass over volume, we're going to say the density, the population density, is the population size it's kind of like the mass over the size in which that population occupies, or the land, in this here is square miles. So area occupied. Okay, and so that's what we're going to use here. So when it tells us 5,000 people per square mile right there, that's density. Okay. So if the area of Clovis is 24 square miles, what's the population? So we could say our density, 5,000, is our population size divided by 24, which is the area in which it occupies. We can cross multiply and get our population is 5,000 times 24, which is 120,000, and our units are people. Okay, so that is part A. Part B, if there are on average 3 people per household, how many households are there? So for part B, we found that there are 120,000 people. Divide that by 3, and we get roughly 40,000 homes or households. And then part C, recent trends predict that in the next 10 years the population will increase by 20,000. In order to maintain the same population density, how many additional square miles must be annexed by the city? So if we add 20,000 to our population, so we're going to have 120,000 originally plus 20,000 more, divided by, I'll say, the area, and we want to keep the same population density, which is 5,000. And so if I cross multiply here, I'm going to get the 5,000 times the area is 140,000. Divide 140,000 by 5,000. We get 28 square miles. And right now we got 24 square miles, so how many more? If we want 28 and we have 24, we need 4 more. 4 square miles.